So today we're going to talk about lots of different lines and geometric figures that I would like you to take notes on. I'd like you to write some definition, and please make sure that you draw an example for yourself in your notes. Study these vocabulary words. Maybe make yourself a list, put them on flashcards. I would encourage you to maybe put the word on one side and a picture and a definition on the other side. Okay, our first three words here, vocabulary words, are parallel lines. Parallel lines are always the same distance apart. They do not touch. These are examples of parallel lines. In real life, railway tracks are always parallel. Intersecting lines. Intersecting lines, another word for crossing lines. Lines that cross, forming four different angles. They cross at some point. Kind of the opposite of parallel lines, because parallel lines are never going to cross. Intersecting lines cross. They have an intersecting point. Perpendicular lines are a special type of intersecting lines. They are lines that intersect, forming four right angles. Perpendicular lines form a cross or a T, and they always form right angles when they cross. Okay, sometimes four right angles. In this case, where they don't completely, one line doesn't cross over the other, you only have two right angles. Skew lines. Skew lines are unusual type of lines. You've probably never heard of them before. Skew lines are lines that do not lie in the same plane. An example of skew line would be two lines that lie in completely different planes. If you look at these two rulers, they're not even in the same plane. A plane is a two-dimensional surface. If you take a look at this math book, for example, these two lines here are parallel. They're lying in the same planes. Skew lines would be an example of this line and this line. Take a look at how I'm holding the rulers. These are skew lines. They're in a complete different plane. Some of you say, well, they're intersecting. Nope, they're not touching, and they're not parallel. They're in completely different planes. Let me see if I can find another example of skew lines for you on this book. When you look at where I have the rulers, again, I'm showing you a different example of skew lines. They're on completely different planes. They're not intersecting. Different surfaces of the book. So skew line, you can kind of see in this diagram here, a three-dimensional drawing on a two-dimensional surface. So the back side of the cube and then the front bottom of the cube are forming skew lines. I'll show you some more examples of real-life skew lines. So here are some real-life pictures. What lines do you see highlighted here? I'm going to turn off the light so we can get a better view of these pictures. The lines that you should see highlighted here and here are examples of intersecting lines. These are intersecting lines, and it looks like, from this view, that they are perpendicular. They're going to form four right angles, although we can't tell exactly. What type of lines are highlighted here? In the lightning zigzag strikes, we can see intersecting lines. These are intersecting lines. How about here on the side of this structure? Again, you can see intersecting lines. These lines are intersecting, they're crossing, they're touching each other. Take a look at these examples, and at this point you can pause the video and see if you can identify the lines in the figures 1 through 7 here. Unpause it when you're finished and we'll talk about what lines you see. In example number 1, in the dice here, these are examples of skew lines. If you look at this line here on the front of the dice, this line here is somewhere on a complete other surface of the dice. It's on another plane. So these are skew lines. Number 2 over here, on the top face of the star are lines that are intersecting. So those are plain old intersecting lines. They're not skewed because they're on the same surface of that star. And number 3, these are parallel lines. You can see they're an equal distance apart. They're never going to cross. Stripes on a flag are parallel lines. Number 4, here we're talking about the sides of one face of this cube, and those are, again, just intersecting lines. But what do we know about a cube? It's made of squares, and squares have right angles in their corners, so these are not just plain old intersecting lines, but they are perpendicular lines. These lines are forming right angles. They're intersecting to form right angles. Number 5 over here, these are parallel lines. The top and the bottom of the milk carton are parallel lines. In number 6, similar to the cube, it looks like a flat 2-dimensional dollar bill, but the sides are forming perpendicular lines. They are forming right angles, so those are perpendicular. And lastly, down here, we've got another cube. This time, we have a line on, it looks like one of the side faces, and this line is on the top surface. So there are lines that are lying on different planes. They're on different faces of that cube. So these are skew lines. Okay. Let's take a look at some angles. We've been talking about lines. Let's take a look at angles. First of all, you should know angles are formed when 2 lines intersect. When 2 lines cross or meet, they form an angle. Okay? Angles can be measured using a protractor. We're not going to talk about angle measures with a protractor right now. We're just going to talk about different types of angle relationships. First word you see up there, kind of hard to read, but says adjacent angles. Adjacent angles are angles that share a vertex and a common side. They're next to each other. They're next to each other. By the way, a vertex is the middle of an angle, okay? It's the point at which the 2 lines or rays meet to form an angle. So this angle and this angle are adjacent. They're next to each other. In this diagram over here, angles 1 and angle 2 are adjacent. Angle 2 and angle 3 are adjacent. Angle 3 and angle 8 are adjacent. You can see they're next to each other. Angle 3 and angle 8 are next to each other. Down here are some adjacent angles. Angle 4 and angle 5 are adjacent. Pause the video and see if you can name a few more sets of adjacent angles. Okay, next word to write down is vertical angles. Vertical angles share only the same vertex and they are congruent. If you copy this diagram over here, angles 4 and angle 6 are vertical angles. They're opposite each other. They're sharing a vertex. You see how they're sharing a vertex? This angle here and this angle here, they're sharing this vertex. But they don't have a common side. They don't really have a common side like adjacent angles. And they're exactly diagonally opposite each other. Something else special about vertical angles is they are congruent. That means they're equal. So angle 4 and angle 6 are vertical angles and they are congruent. Can you find another few pairs of vertical angles in this diagram? Pause the video and see if you can name some. Hopefully you've had a chance to think about vertical angles. If you look at our diagram here, we already talked about angle 4 and angle 6. So angle 4 and angle 6 are vertical. Did you see that angle 5 and angle 7 are also vertical? Angle 5 and angle 7 are vertical and congruent. There are some up here as well. Angle 1 and angle 3 2 and angle 8 are also vertical. They're diagonally across from each other, and they are equal. They're congruent. So, knowing what I just told you about vertical angles, I want you to copy this diagram, copy the lines and the numbers that you see, and I want you to see if you can figure out the measure of some of these angles. Okay, as you're looking here, this angle right here, we're given the measure of it. It's 79 degrees. That little circle there means degrees. It's 79 degrees. Which angle is vertical to this angle that measures 79? It's angle 7. That means angle 7 is also 79 degrees. We can figure that out. Take a look over here at this diagram. We are given the measure of this angle here. It's 162. It's kind of hard to see there on the video. I'll write that in. It's 162 degrees. Do you see which angle is vertical to this angle 162? It's right here. Angle 4 is equal to the angle 162. They're vertical. So that means it is also 162 degrees. Okay, we don't know yet the measure of angle 1 and angle 3, but I hope you see that they are also vertical. Angle 1 and angle 3 are vertical. We're going to learn how to find the measure of those tomorrow. And over here in this diagram, I hope you also see that angle 5 and angle 8 are also vertical. So we have learned a lot of vocabulary so far today. We have learned about lines. We've learned about parallel lines, perpendicular lines, intersecting lines. We've learned about skew lines, and we've learned about vertical angles. There are 2 more vocabulary words I'd like to go over with you today, and I'm going to turn on the lights again. Two more concepts, and these kind of have to do with angles again. I want you to write down the words complementary angles. Complementary angles. Complementary angles are 2 angles that when you add them, they make 90 degrees. So in complementary angles, the 2 angles form a right angle. Complementary angles are 2 angles that form a right angle. So the definition is right here. The measure of the sum equals 90 degrees, and they make a right angle. Copy the drawing as well, and you can see that an angle that measures 42, highlight them here, this angle that measures 42, if we add it to this angle that measures 48, together they equal 90. 42 plus 48 equals 90. Together they make a 90-degree angle. Together they make a right angle. You see that square corner? So complementary angles are 2 angles that equal 90. Can you think of some other angles that would be complementary? Can you give me an example of 2 numbers, 2 angles that would be 90, equal 90? Pause the video and think about it. Here are some more examples you might have thought of. There's some obvious ones. 40 degrees and 50 degrees. Those would be complementary angles. 30 degrees and 60 degrees. Those would be complementary angles. There are some obvious ones like 89 degrees and 1 degree. That would make 90. There are many, many, many examples of complementary angles. One more concept, one more definition for today, and then we're finished. Supplementary angles. Supplementary angles are 2 angles that, when put together, they make 180 degrees. 2 angles whose sum is 180 degrees. And you can write down that they form a straight line or also called a straight angle. Two supplementary angles, two angles that make 180, form a straight line. A straight line is always 180 degrees. So in this diagram here, we have this angle is 120 degrees. And then we have this angle, which is 60 degrees. 120 plus 60 is 180. Doesn't always look like this. You could have a straight line that's going this way. You could have one angle here, one angle there. Maybe this big angle is 150 degrees, which means this angle would have to be 30 degrees, because 150 plus 30 is 180. It could be maybe sideways, like this. You could have two angles that are almost equal. Maybe this is 80 and this is 100. I'm just estimating here. 100 plus 80 is 180. So two angles that form a straight line and their angle measures equal 180 degrees are called supplementary angles. Okay, we've went over a lot of vocabulary today. I want you to look through your notes, and I want you to make sure you have all of the following words. Let's go down the checklist right now. Make sure you have all the following vocabulary. You should have parallel lines, intersecting lines, perpendicular lines. You should have skew lines. You should have adjacent angles, vertical angles, complementary angles, and finally, supplementary angles. Do you have 8 different vocabulary words? Make sure you have definitions and pictures, examples to go with those. If you don't, rewind the video, go back through, and make sure you have an example for each of those words. Study them. Yes, it's going to take a little bit longer than usual to grasp these concepts, and I appreciate you hanging with me through this long video. And we'll come tomorrow, we'll look at some more real-life examples of all these different types of lines and angles, and we'll practice using them and identifying them. See you then.